Okay, cool. So guys, from the statistics, we are going to cover fourth module. The name of the module is data visualization. Okay, so what, why we need to learn, or why we require the data visualization? Anybody? So, Krishna, can you
To
please tell me why we require the data visualization?
basically to show the trends or show the data in different formats
Yeah,
uh, for the managers. Yeah.
yeah. For example, let me consider this is my data set. Okay. So data set means there we do have various features like in a tabular format. Okay. Let me take it in one data set like an employee data set. So employee ID and employee name, employee income, employee education level, and employee experience. So this all kind of stuff we might have it, right? Okay, which is not something like there might be the company having more than 1 lakh of employees. Okay, that particular situation we have to maintain this all no 1 lakh of employees, and meanwhile ex-employees details also you should maintain it, right? Okay, so what is your as a stakeholder, I want to understand and what kind of employees or um they're switching our company to another company. Okay, simply we can say that it's a churning. Okay, churning means changing the company or changing the same and everything. It could be like a churning meaning actually. Okay, so I want to understand that particular thing. So for understanding this particular patterns and what kind of employees or what kind of people are churning our company, so that you want to understand the pattern, so we can do with help of data visualization. Are you following? Understand the patterns, okay, of data. Next point is might be some of the employees are getting very high salary, right? Okay, and for example some of employees are getting 1 CR or 100 CR, something like that also. Okay, and most of the employees are getting like in the yearly basis like 50 lakhs or 30 lakhs or else 4 lakhs, something like that, right? Okay, if you compare this 10th 100 course, and if you compare with this 10 lakhs or 4 lakhs, and most of the salary which it might be now a 1 CR range only, 1 CR to a 50 lakhs range only, right? So this 100 CR or else this 4 CR, it might be or some situation they might be getting only 1 lakh only. Okay, so in a yearly basis. Okay, so this kind of data we can call it as the outliers. Okay, the data, it is a valid only, but the data which is not within the region of the or within the range of the mean. Okay, it might be if we compare that particular only some of the sample which is not in the space. For example, all people are in sitting in one location. These guys will sitting in a different location. That kind of a scenario. Okay, for example, and most of the data it was distributed this particular area, but some of the data it was um some of the data was some situation only uh, one or two people, what happened, there might be, or else I cannot say this kind of thing. So this is kind of data, if we see this kind of patterns, that we can say that it's outliers. Okay, got it. And so different kind of patterns we can see that and if your data which is not within the range, it might be a far away to your you know most of the data, that particular thing we can call it as the outliers, so that we can able to detect the outlier. I hope you understood, right? What is outliers? It which is not within the range of your central data. Okay, and meanwhile we can understand that trends and all we can understand the trends, and we can easily finding the meaningful insights and all. And so good visualization, we what we can do, we can see, we can understand that your entire data and all. Okay, so what are the most common techniques? What are the most common visualization techniques generally we could see, we could apply actually? Okay, so the first visualization tool, it could be like histogram. What is the use of this particular histogram? So this particular histogram, it could help you for to distribute of a single variable, of a single variable. For example, I want to be distribute the income of employees. Okay, their income is our single variable. So you're going to be distributing that specific element. Clear? Next one is, you most of the time we can see this particular name. It's a box plot. So box plot, it could help you for not only for distribute, it could help you for outlier finding also. With help of the box plot visualization technique, we can identify the outliers. So in generally, box plot something like this. Okay, we can see. Okay, so if you plot the box plot, you might be see this kind of data points. These are all outliers only. These are all outliers only. Okay, so this is your quartiles and unstacked like an interquartile range, or with help of interquartile range we can see that these all things. But box plot could be something like this. You can see this kind of graphs. Okay, and with help of the box plot we can easily identify the outliers and how many outliers are there and how it was distributed, whether the more outliers are there or very less outliers are, that all we can see it actually. Okay, next one is a pair plot. Pairplot, it could help you for a relationship between the multiple variables. For example, if one variable, whether it is depending on the another variable or not, and how it was, affecting the second variable. So that all kind of relations, and we can easily between the multiple variables, multiple features. Okay, and so next visualization technique is heat map. So coming to the heat map, it could help you for correlation. Even in a pair plot, it could help you for finding the relationship, or plotting the relationship between the multiple variables only. But in the same way, heat map also we can do. It could help you for how strongly one variable is affecting the another variables. So with help of numbers and all, we can see with help of a correlation matrix. So the correlation matrix only we can call it as the. So correlation means, so how strong, or strongly one variable is affecting the another variable, that we can call it as the correlation, right? So that correlation matrix we can call it as the heat map. And next one is like bar plot. What is the use of the bar plot? So it could help you when we have some kind of categorical data, like qualitative data kind of stuff. You might be see that, right? So for comparison purpose, for comparing comparison between the categorical variable, then we can use it. Bar plots and all, scatter plot, scatter plot. So scatter plot also, it could help you for relation between the multiple variables, or relation between the two numerical variables, that we can use the scatter plot. Pair plot, it is a multiple variables, but coming to the scatter plot, only two numerical numbers only. Okay, this all kind of stuff we'll see with help of a Python programming language. Let me share my screen. Let me share my coding screen. Are you guys are following or not?
Yes,
Yes,
Sanjay.
following. Yeah, Anjan, adding to this line chart also, comparison of two variables, no? It's like bar plot only.
This means that line plot.
Line chart.
Yeah,
Line chart will be there, no? Line.
line chart, right? So
Line chart.
it's a just it's a line scatter plot. It's a bubbles. Okay. So but line chart it is connecting each and every data points. Okay.
Okay.
Yeah. See guys, I know. Okay. So okay. See guys, I'm going to be creating agentic AI application, one agentic AI application. Okay. So this agentic AI application, it is project manager agentic AI application. Like if stakeholders come and give the project, so automatically our application will you know create the sprints and assigning the task to the individual agents like here various developer agents and all I can going to be creating it. So this particular agent what it is doing, it will be do entire task, okay, without any human interventions. So this particular project manager agentic AI application, it will able to complete that entire project, okay. So that exactly the project manager agentic AI. There also we required some of the developers as well. So that kind of project, I'm started with my own. It's kind of research. Okay, not completed yet. It's a lot of things we required. Just showing you. Oh God. Okay. Yeah. Okay. Cool enough. Hmm, Visualization techniques, right? Yeah. So if you want to be work with like visualization kind of stuff and all, like what we can do. Uh, First of all, we need to import the important libraries. So which is like pandas PD. And guys, while I'm explaining, you can try to execute from your end also. Okay. So we required various visualization libraries like SNS, and we need to import Matplotlib as PLT. Okay. So those are the main important libraries. I know generally we could use it. And so I think we do have our data set, right? What is our data set? Let me take it my example of data set. Okay, I'm taking the previous example only. I'm not taking any new thing. Okay, let's take it this data. First, you must have a data. In generally, we can take our Excel sheets and all as a data, and then we can do the visualization and all. Later on stage, definitely we can do it, but we'll take in very simple data and all. Okay, yeah. So this is how we know we can able to create our data set and all. Now my point is that I would like to go for apply our visualization techniques, right? Okay. The first one is histogram, right? How we can do it like histogram. Okay. So you already know that how histogram it could help you for distribution of the numerical variables. Okay. So for that we can have in Seaborn we have histplot is there. Okay. So for this particular histplot, we have to provide our data, your feature from your data frame. Okay. And this is like KDE, like it could be like true. And what is the title for that? If you want to make it like title, and this is what? this income distribution, right? We are going to be we're going to be distribution. We are going to be finding that how it was distributed, that income variable, so that I'm giving that particular name, distribution. Okay, income distribution. And I want to make it like X label and all. Like with help of this one, we can make it like what could be the X variable. And I want to make it like Y variable also. Then we can have Y label. So if I give the Y label, then it's a frequency. First of all, it's a frequency. Okay, and Y variable, it's a frequency. And so with help of this show, we can see that that visualization graph and all. Okay. So this is histogram, right? Okay, it's the income distribution. So this is how we just have direct function is the list plot. With help of that one, we can see that how data it was distributed, and especially it's a numerical kind of stuff. Okay. Now we'll try to go with box plot. So for same for box plot also we have box plot method is there. Okay. For the box plot, we can provide our X data is our df dot income. So we can give it anything actually, whatever the variable you want to be understand that particular thing we can provide it. It will box plot. Okay. The next one is PLT show. See, I told you, right? See, this is some value which some dot we see somewhere else. Okay. See, here the data is very small data, small amount of data. That's the reason, graph I showed you some kind of, um, mm, visualization, right? But here it is different thing because here the data points are very small. That's the reason we can see. But, one beautiful thing is like here we can see one bubble in somewhere else. Most of the data it was in this particular area, but now it but one particular data point it was somewhere else. So this kind of data points we can call it as the outliers. Okay. So if we give it like pair plot, we have another method, another method method for display the visualization. I mean multiple. If you want to see the relationship between the multiple variables, then we can use the pair plot, right? So here we can give the entire data frame, then automatically it will give you that relationship between the each and every features within your data set. So that's the reason we are giving the whole data frame. Okay. So plot, pair plot, and so it, you see it. See. So here we have age, income. Only two numerical variables are there in your data set. So those what are the numerical variables are there in your data set? And those two variables, if you have the three variables, then you might have the three variables over here, age, income, something like that. Okay. If you have the 10 numerical variables are there in your data frame, so then each and every numerical variable, how one is another one is depending. So that kind of visualization, or we can see that relationship between the each and every features between those things, then we can use the pair plot. This is the method for that. Okay. And we can have the heat map is there. So with help of the heat map, then what we can do, we can see that correlation matrix. But if before we are displaying the correlation, then we should have the correlation data. For getting that correlation, we have uh, COR or function is there in data frame. Then with help of this one, we can find the correlation between each and every features. And so that particular values we are holding into this particular variable. And so that particular data we are giving as input for heat map, then it will be displayed. Okay. And equal to true. And so if you wanted some kind of color kind of stuff, then we can give it CMAP. So here we have different arguments are there. We need to be explore it actually. So don't worry about those all things. We can try it actually. Okay. Okay. So title correlation matrix. So because so could not convert our string to float because so when we are working with this kind of stuff like so make sure that it could be numerical stuff. Because of that one we are getting this kind of error. But you know um, let's take same example. But this time I'm going to be creating that new data. Same, I'm not taking this gender and all, okay, because it is numerical. It's not numerical, right? But you can able to convert this categorical to numerical with help of one hand encoding and all or label encoding and all. Okay, now we can try with correlation. See, this is how the correlation matrix will looks like. So the age and income, it was negatively correlated. That means it is correlated but negatively correlated. If age increases, your income might be decreases. That's maybe that is a okay relation we are getting. Okay, because of the data actually. The data what I have it according to that one it was given. It is not exactly the right in a real time, but as for the data it will be given. Okay, clear, right? Next one is bar plot. So I told you, right, bar plot, it could help you for, you want to understand that you want to understand the categorical data and all that, but that particular situation, we can give it like, bar plots and all. So let's try with bar plot now. So for bar plot, it is like, counting kind of stuff, how one particular variable or one particular feature, one particular attribute, how many times it was repeated. For that, we can use the count plot. Okay, for this particular count plot on it's your bar graph. Okay, the gender, we're taking the text variable is our gender, and from the data is our data frame. Okay, and the plot is we're going to be giving the title is gender count. Okay, and plt x label gender plt y label count. So okay, so that's what. Okay, this is our data frame, and from the data frame we are comparing that within the same variable or within the same feature, you might have multiple elements are repeated. And so one each and every attribute or how many times or each and every element how many times it was repeated, that I want to be compared with help of bar graph and all. Okay, now scatter plot. So scatter plot, it could just help you for relationship between only for two numerical features. So SNS, we can have a scatter plot, and there we can provide line also, like line plot also. Okay, so uh, so here it is giving like bubbles and y equal to your income. Okay, and data is our data frame. From the data frame we are taking the x value and y value, and we're title is what? Our title is age versus what? Income, right? And let's see. Y label is your what is Y label? Y label is income, right?
Yeah.
Okay. X label is
Age.
yes. X label is age and plot show. So this is how we can see the relationship between it's a scatter plot so that it's a we are getting the dots and all. Okay. Uh, you can have the line plot. So with help of line plot, we can see that we are connecting each and every data point with a line. Okay. So like this, we have so many data visualization techniques are there. Okay. Who really working on data analytics analytical side. This visualizations is definitely required. But I want to tell you guys, technology is already moved too much. Uh, um, fast and it's moreover it's agentic and AI like generative AI and so whatever the work we are doing so that all kind of stuff we're going to do with help of agentics agents actually AI agents. Okay, agentic AI is different and agent AI is different. Okay, it's a kind of agents. Okay, so whatever the work we are doing, some of the work and so definitely it can able to achieve approximately more than 50 to 60% of the work currently the agents are doing. Definitely, it can reach around 80 to 90 percentage, but rest of the 10 percentage as a developer we only do it because of that one. If any project, it might be take a lot of months or years, okay, to finish it. But when this particular agentic AIs and artificial intelligence concepts comes, like instead of completing that particular project within months or within weeks only, we can able to finish out it. That means the productivity will increases. Okay, so as per the technology, as per the trend, we need to move actually. If you sit only, I want to learn only these things, and the situation's going to be tough, and so mastering into the technology is very important because it's a pretty important this time. We don't know how market is going even outside global recession and global marketing and all global market and all. It's bit of a scary. Okay, so I always request to the who are learning Python or AI or generative AI. It's a kind of it's a good thing. It's a good step. I always tell you. Okay, so because you know even it is unpredictable. It's a kind of in a 1 year or 2 years back we can predict like what is happening in next 1 year or 2 years, but because of the trending things and global recession and all, it's a bit tough to even prediction as well. Okay, so hope you understood the importance of the things. Don't spend too much time on unnecessary things. Concentrate on very important things and all, at least basic stuff. If you know it, then and when we are getting some kind of code and all, we can understand why this code is, what is the use of this code. That level, at least we need to understand. Okay. Mm, yeah, very fast we need to move towards into the generative way very soon. But I can directly start that particular stuff without this all stuff also. But in future you might be face a lot of issues like if you get a code and all from if you implement the code and all, and if you got a code from any one of the source and all, like you it might be bit tough to understand that what is the use of this particular code and all, right? Okay, so that's the reason I'm just giving you from the scratch. I hope it could help you. Of course, it will take time to understand and all, but whatever you learn, we are not using too much. But if you know these things, you can handle anything in a easy manner. That's my question. That's my suggestion. Okay, clear, right?
Yeah. Clear.
Okay. The next module is like probability. So probability means like it could help you to measure the Wait a minute. Sharing. Let me share my. Okay. So now I would like to talk about a probability. This is pretty important in data science perspective or machine learning engineer perspective. Okay. So what is probability? What is a probability? What is a probability?
Uh, it is a measure like how likely the event is likely to happen, like probability
Yes.
of happening an event.
So you feel that you want to let's take an example of Trump only. Okay. So in USA there are every 6 years or 4 years or 5 years elections. Hmm?
4 years.
Every 4 years in US there could be elections, right? Right. So you want to go with we would like to measure the how likely the Trump will be going for in the last election. Okay. So before conducting the elections and all, most of the people are believing that Trump will become like a president of America, right? Okay. So when we are doing experiment or events, one particular event, how likely it will happen, and that we can able to measure with help of the probability. So I can say 90% of time, I can say 90% there might be chance of getting that particular Trump will become like a president of USA in the last 6 months or 7 months back. This is the trend thing happened, right? Yes or no? So there we are representing, measuring that how likely one particular event will happen. So before happening only we are predicting it, right? So that kind of stuff we can call it as the probability. So in generally the probability value it was from 0 to 1. So 0 indicating that there is no probability of happening that particular event. That means impossible. 0 means impossible. Okay, okay, whatever it is. So generally 0 to 1, and one event is like some situations it could be happen actually. So the range of the probabilities it's a 0 to 1. Okay, let's take some example. If you toss the coin, okay, if you toss the coin, what is the probability of getting the head? So if you toss the coin, the sample space is like you might be chance of getting the head or you might be getting the chance of a tail, right or not? So my probability is what I want to find? I want to find the probability of getting the head. So probability of H. So if you want to find the probability of H, then the number of samples of H by total number of sample space simply. Okay, total number of samples. So how many times my H was repeated in my sample space? One time. And total number of events I have it's a 2. So 0.5, right? Okay, so the probability of when you toss the coin, the probability of getting the head, it was like 0.5. Am I correct or not? When we are talking about the probability and all, okay, so the key terminologies is that experiment. So you might be see this particular name, experiment. Okay, this is a one experiment only. Okay, experiment and sample space or sample space. Sample space means no the all the outcomes of it is all possible outcomes. All possible outcomes w- when we did experiment. Okay, so experiment means action that leads to be output or outcome. When outcome. Okay, so that is an experiment. Event means, so you might be see this kind of terminologies. Event means what? It's a subset of sample space. It's a subset of a sample space. Within H is one event, tail is one event, right? Okay, these are the subset of a sample space and a probability. It's a likelihood of an event. Probability. Okay. So these are the terminologies we might be heard about it when we are talking about uh, probability and all, likelihood of an event. So that is exactly the key terminologies. And what are the types of probabilities we have it? What are the types of probabilities? What is the types of probabilities? So there could be various types. The first type is a theoretical. Theoretical. So that means what is mean that theoretical? What is mean that theoretical probability? Theory means what? Based on the reasons and all, reasoning and all. So we are not doing any kind of experiment on all. Practically, we are not doing, and we are not doing any kind of experiment based on the reasoning. So based on the reasoning, we're going to be finding that we are going to finding that the probability that we can call it as the based on reasoning. Based on the reasoning, we would like to go for calculating the probability that we can call it as the theoretical probability. Second one is experimental probability. Experimental. Experimental means you did an experiment. There we are getting some results. So based on experiment, based on the experiment, you did one particular experiment, and from that one we are getting some kind of outcome. And so there is no assumptions and all. You did the experiment, and there we are getting a lot of outcomes. And from that particular outcomes, we are doing that some kind of a probability that we can call it as the experimental probability. Okay. And third one is conditional probability. Conditional probability. Okay. So coming to the conditional probability, so one particular event, it might be happen based upon another event. Okay. So probability of event, it might be given by the event B have been occurred. Okay. So for example, you might be chance of getting if you want to get the high salary, then first of all you should clear that interviews and all, right? Okay. See, yes or no. So if you want to get the probability of getting that, if the probability of getting the salary this range, so the probability of getting the interview also, it's a kind of stuff, right? Okay. So one particular event, it might be the probability of event A, it might be given by the another event or event B. Okay. Event A, okay, given by event B. Okay. So that we can call it as the um, conditional probability. Okay. Last, which is joint probability. So probability of two events are happen together. Both will happen together. So A and B both will happen together. That we can call it as the joint probabilities and all. Okay. Is it clear?
Yes, clear.
Anjan, can you scroll little up? Okay, experiment probability, condition probability.
Joint probability.
Okay.
Okay. Now let's share my code area. Let's see this all stuff with help of Python as well. Okay. So some kind of basic probabilities we'll see. Okay. So most of the time it's a kind of random kind of stuff. So that's the reason I would like to go for import one particular random attribute. So here I would like to go with finding the probability of the coin. When you toss the coin, I want to go for finding the probability of the head and all. Okay. So that's the reason I can have the heads and tails. Okay. These are the two outcomes when you flip the one single coin. Okay. So result So random dot choice. So random dot choice. There we do have we don't know what element we will get over here. Okay, it's a random dot choice from your outcome. So in outcome, we have two options are there. From this particular option, we are going to be choosing any one of it. We don't know what it is. Okay. And so print, we would like to go for print coin toss results. Simply we can say that, it's a result. Sorry, it's not set, it's a list, because set the probability is what is the characteristics of the set. So all should be unique elements. If you hold multiple elements and even some of the elements, it might be repeated. So it may be considered as the only one element. So that is a problem. That is the reason I have to take it as a list only. Okay. See, same program, if you run it one more time, so there might be chance of head, right? Okay, yeah. Every time here it is a tail because choice. But some situation we might be get head also. Sorry, I'm not able to get head. It's kind of, yeah, now we got head. Okay. See guys, random draw choice is a method. We don't know what element it could be choose. It's randomly it can be select. Clear? There is no specific, there is no meaning at all. There is no specific rule for that. Is it clear? So now I would like to go for calculating the probability of, I did the same experiment. I did the flipping the coin 1,000 times. Okay. And how many trials I did? So I did that, 1,000 trials. Out of the 1,000 trials, I would like to go with holding that all the results. And so I'm taking that random dot choice outcome. Okay. Per I, it could be anything, you can give it anything, I or some character, because as per the, we have to repeat the same, we have to choose 1,000 times, we have to repeat this particular thing 1,000 times, right? That is the reason I'm using the for loop list comprehension range of trials. Okay, so I repeated, this is the for loop as repeated. For each for loop repetition, how many times it can be repeated this for loop? 1,000 times. 1,000 times, 1,000 times from the 1,000 times. So from the head and tails, it can be considered only one element every time. So randomly, it can be choosing it. Okay, that's the reason. The results, it might be some situations the results are tails, and some situation the results are head. Okay, first two heads and tails and heads and tails and heads, right? Like this, it is choosing 1,000 times out of the head and tails. Some elements it can be considered, like I want to find that length of it. So the length of the results, it definitely it's 1,000. Okay, so 1,000 times you flip the coin, and for each time we're getting some outcome. It's a purely choice based. And now I would like to go for finding the probability of head. Okay, probability of head. If you flip the coin, what is the probability of getting the head? So if one time it is of course it's a 1/2, but 1,000 times you flip the coin, right? Okay, so that particular situation, what could be the probability of it? Head probability. So head count. First, we need to go for finding the head count, right? So how can you calculate the head count? So out of the results, and I would like to go with use the count method. And here I am giving the input is head. So how many times heads has been repeated? Okay, so now I would like to go with finding the probability of head. So probability of head is head count by what? Total number of trials, right? So that trials. So now I would like to go with fine. print the probability of head. This is the one experiment. I did that, same experiment 1,000 times. See, 0.491. It's approximately 0.5, right? Sir, no. When you flip the coin, you might be chance of getting zero, either head or tail, heads or tails. And so, but if you, there might be chance, it's very tough to get it. What could be chance of getting the head and all, right? Okay. So if you flip 1,000 times repeated, so this particular situation, if I ask the question, what could be the chance of getting that head in next time? So you can say 0.49 percentage or 0.49 percentage, there might be chance of getting the head in if you flip the coin. Okay. So this is like, experimental kind of probability. Okay. Let's see the conditional probability. Okay. You might have a data of, okay, gender and all. So like there could be gender. So don't take it personal, because whether one particular element female will buy or male will buy, that we would like to go with, figure out it. And so to have a data of a female and a male, 2 times. Okay, I have a 5 data points. Okay, and male and female, and I have to create one more variable. That variable is purchased. Okay, so the male is this particular situation purchased. Okay, female no. Okay, and here one another scenario, female has purchased the same product. Okay, and so in one another scenario, male was not purchased. You can say it's a no. Okay, next time let's say yes. So my next question is, I would like to go with what is the probability of that customer is male and purchased. Okay, so there we have two options. So let's go for creating the data frame. PD dot data frame is a method. With the help of this particular class, we can give it your data. Then data frame has been created. Now my question is, what is the probability of, what is the probability, okay, that a customer is male, the customer is male and purchased. So here we have two things, and the customer is male and purchased. He must be purchased. That kind of probability want to get it. So in a male also, some of the customers will purchase, some of the customers are not purchased, right? And in a female also, some of the customers are purchasing, some of the customers are not purchasing. So this particular situation, the male, I want to go with finding the probability of male and purchaser thing. So simply I can say probability of male and, okay, purchased. So what is the probability? What is the formula for that? Hmm? So first we would like to go with finding the count of male purchased, right? Only male purchased element. How you can do it actually? So there we can apply some kind of conditions from your data frame, okay? And see, here we have two things. One is data frame. From the data frame, age must be what? Sorry, it's age or gender? Gender, right? Gender equal to what? Is it male or not? Say yes or no. Okay, gender is a male, and operator, we should use the and operator. and keyword. In it's a numerical pandas, and or we can use the ampersand only. Okay. And from the purchased thing. Okay, so purchase. So I want to take it like only yes kind of stuff. Okay, what is the probability of purchase mail and purchased thing? Okay. Next, we would like to go with finding the probability. Finding the probability length of this mail purchased thing, total number of elements by and length of our data frame, total number of elements. So this is our probability of mail purchased, mail and purchased thing. So one particular element, it might be depending on the another element. Okay. So this kind of stuff we can call it as the conditional probabilities and all. So that's how we can able to use the Python for different scenarios. And by tomorrow's session, what I can do, we can see various probability distributions like uniform distribution, normal distribution. Okay, and that stuff will go through it. Once it is done, then I can start the inferential statistics. Okay, like random sampling, stratified sampling, systematic sampling, clustering samplings, central limit theorem. Okay, confidential intervals. So this all kind of stuff we'll discuss in the next sessions. Okay. Thanks, guys.
Okay,
Thanks for your time. Yeah.
yeah, Anjan, quick question. Can you go to that trails equal to 1000 we have, right? Where we wrote if for condition loop, for loop. Just
It's a list
I missed.
comprehension. It's a list comprehension. First, we are implemented
Yeah,
the for, and so this means this list it might be repeated 1,000 times. For each time, we are this is the statement is being executing. Okay. For each loop, this statement is executing, and this outcome we are holding into the this result as a input. It appending. Okay. First element, first time this is repeated and taking that element taking this result and keeping it. And next time another for loop is repeated and the result will be appending to the next element. This is how each and every time the for loop is repeated, and for each for loop, this is the statement is being executed. The result we are appending the list. That list name is result. That is the meaning of it.
okay, understood.
Yep. So I hope you understood for this particular class. It's a bit old things actually. So recollect it your um, logics and all. So it could help you for learning perspective because implementation is already went in a next level. Okay. Uh, cool enough, guys. Thanks for your time. Take care.
Okay, thank you.
Oh, did I record this particular session? Yes, I recorded. Sorry.
Yes, yes.